Hello dear student friends, morning all of you. This is your chemistry teacher, Dr. Shokatali. Today we are going to discuss a new topic. The topic for the discussion today is your Fridel-Crafts alkylation of benzene. Fridel-Crafts alkylation. And in continuation of these aromatic electrophilic substitution reactions, we have discussed number of things in the previous sessions. One is nitration, sulfonation, halogenation, and today in the series of these aromatic electrophilic substitution reactions are concerned, the topic now chosen for the discussion is Fridel-Crafts alkylation of benzene, or simply Fridel-Crafts alkylation. Fridel-Crafts alkylation. It's a name reaction as far as this particular name reactions are concerned in organic science. Almost all the name reactions are very, very important. Important in the sense, this is important for every examination, end semester examination or final examination. Also the same thing, these name reactions will help you when you are facing the interview as far as the pharmaceutical industry, the industries are concerned in general. This has a great value. Therefore, we remember in memorizing all these name reactions, whatever the name reactions comes in organic science, all the reactions are very, very important. This will help definitely in future. The topic is Fridel-Crafts alkylation. What to do for this Fridel-Crafts alkylation? In the case of nitration, we are treating benzene with nitric acid, mixture of nitric acid and sulfuric acid. It will be converted into nitrobenzene. In the case of halogenation, we are treating benzene with halogen. You will get halogen substituted benzene. In the case of Fridel-Crafts alkylation, you are treating benzene with alkyl halide in presence of aluminum chloride as a catalyst. You will get toluene as the product plus hydrochloric acid. I repeat, the reaction is simple. Benzene, you are treating this with your alkyl halide, say for example methyl chloride, in presence of aluminum chloride. Aluminum chloride is a catalyst. This remains standard as far as these Fridel-Crafts reactions are concerned. Benzene reacts with aluminum alkyl halide in presence of aluminum chloride as a catalyst. You will get toluene as the product. Benzene reacts with CH3Cl in presence of AlCl3 as catalyst. You will get CH3 plus HCl. This is your toluene. This you know, this is your benzene, no need to write again and again. This is your methyl chloride and this is your aluminum chloride. So the reaction is simple. In Fridel-Crafts alkylation, name reaction, You are treating benzene with methyl chloride in presence of aluminum chloride as a catalyst. The product is toluene plus hydrochloric acid. See the board. Try to understand the reactions. Benzene reacts with aluminum chloride as catalyst with your methyl chloride. Benzene will be converted into toluene in a reaction, namely Fridel alkylation. This is about your reaction of this Fridel alkylation. Now we are going to discuss the mechanism behind this Fridel alkylation of benzene. See the board again. Are you clear? Now I am going to erase this. We are going to enter the mechanism of this Fridel alkylation. Yes. The topic now is mechanism of Fridel alkylation. Mechanism of Fridel alkylation. As usual, we have three different important steps. One is formation of electrophile, in step number 2, attack of electrophile into an aromatic system, followed by the resonance, followed by delocalization of, followed by the stability, followed by the movement of electrons inside. Thereby you will get a number of resonance, so-called resonance structures. Finally, in step number 3, removal of proton so that the aromatic system will be restored. Finally, you will get the substituted product, electrophile substituted product. There are 3 different steps. Formation of electrophile, attack of electrophile, finally the formation of the original product. Number 1 is your formation of electrophile. Step number 1 is your formation of electrophile. In step number 1, methyl chloride reacts with aluminum chloride, will be converted into CH3 plus AlCl4 minus. In step number 1, formation of methyl carbonium ion. Carbon carries positive charge. This group is methyl group. Methyl carries positive charge. CH3 plus is your electrophile as far as this Fridel alkylation of benzene is concerned. This is your electrophile. This is the one going to attack your benzene ring. And the second one is AlCl4 minus. So step number 1 involves the conversion of methyl chloride into CH3 plus electrophile. Now step number 2. You know that step number 2, similar to the previous one, attack of the electrophile, that is CH3 plus takes place. This comes close to this and there will be formation of negative charge. As a result, this you will get, that is CH3 proton we have plus charge here. Yes, this is the thing you get in step number 2. Now come to step number 3. Step number 3, as usual, simple thing, plus CH3 proton we have plus AlCl4 minus. This will be removed by this AlCl4 so that this will be converted into AlCl3 plus HCl plus CH3. Alkylated product, that is toluene, you get finally C6H5CH3 is your toluene. So this explained, this particular 3 different steps explains how you are preparing toluene with the help of the mechanism concerned of this with respect to this Fridel-Crafts reaction. Mechanism of Fridel-Crafts reaction involves 3 different steps. Step number 1 involves the formation of your CH3+, which is your electrophile in this particular reaction. Step number 2 involves the attack of CH3+, that is electrophile into an aromatic system takes place, leaves that one in the second step as well, you know that subsequent thing. And in step number 3, the product what we get in the second step will undergo a small interchange. AlCl4 minus attracts your proton, leaving the bonding electron. That bonding electron will come into an aromatic system, so that the aromatic system is restored, plus AlCl3 plus HCl. The final product as a result is your toluene. This is the mechanism of Fridel-Crafts alkylation. Are you clear? Yes. We'll come to the next one. As far as Fridel-Crafts alkylations are concerned, we have some limitations are there with respect to the Fridel-Crafts alkylation. That is, once the Fridel-Crafts alkylation of benzene is started, it is very difficult to stop with the formation of one alkyl introduced benzene. That is, say for example, in the case of toluene, it may continue and you may get di-substituted benzene, dialkyl substituted benzene, or sometimes a trialkyl substituted benzene. This is the one drawback. And apart from this, one more drawback is there, that is the alkyl group. Say for example, if you are using N-propyl chloride in presence of aluminum chloride as catalyst, the N-propyl chloride, which is an alkyl group, which is an alkyl halide, nothing but an alkyl halide. When we use specifically this alkyl halide before undergo the reaction, so called your Fridel-Crafts alkylation, this may undergo rearrangement. You are using N-propyl alkyl, N-propyl chloride, so that the product what we expect, what we are expecting to get is your propyl substituted benzene, but you may not get this. Instead, you will get cumene, a rearranged product. Unexpectedly, we are forced to get the rearranged product, a beautiful product, namely the cumene. I'll write down that particular reaction. See the board again. The reaction is benzene reacts with your CH3, CH2, CH2, propyl chloride in presence of your aluminum chloride. You will get CH3, one more CH3. This is your cumene. This is your cumene. Plus, as usual, HCl. So the alkyls are the use of N-propyl chloride. This is where propyl chloride. This N-propyl chloride reacts with benzene in presence of aluminum chloride in this Fridel-Crafts alkylation. The benzene, instead of giving propyl substituted benzene, that is a 2-propyl benzene we expect, and that should be the product in this particular reaction, but we are not getting. Instead, the propyl group undergoes small rearrangement so that we get this type of rearranged product. This is your cumene. This is one more drawback. So the first defect of Fridel-Crafts alkylation of benzene is concerned. The very first defect is it is very difficult to stop after the introduction of one alkyl group into benzene. It may lead to di-substituted benzene, di-alkyl substituted benzene, or sometimes a tri-alkyl substituted benzene. The second important defect of this Fridel-Crafts alkylation is concerned. So for example, if the alkyl halide, if the alkyl halide is N-propyl chloride, the expected product should be your propyl substitute, that is 2-propyl benzene. We are not getting this particular product. Instead, we get the cumene, nothing but the rearranged product, which is nothing but rearranged product. These are the few drawbacks as far as the Fridel-Crafts alkylation of benzene is concerned. See the board. I'll give you time. Try to understand the concept written on the board. Enough, I think. Enough, I feel. Yes. Now, with this, we are closing the discussion on the Fridel-Crafts alkylation of your benzene. I repeat, Fridel-Crafts alkylation refers to treatment of benzene with alkyl halide. Say for example, methyl halide in presence of aluminum chloride as catalyst, you will get toluene as product. Methyl CH3 plus is the one that acts as an electrophile in this Fridel-Crafts alkylation is concerned. Regarding the mechanism, as usual, similar to the previous one, nitration, sulfonation, halogenation, etc. There are three different steps involved here also. Step number 1, formation of, leads to the formation of your CH3 plus as your electrophile. Step number 2, attack of the CH3 plus into an aromatic system. Step number 3, formation of the final product, that is your toluene. Regarding drawbacks, it is difficult to stop with the introduction of just one alkyl group. It may lead to di-substitution or tri-substitution. Number 2, if the alkyl halide is N-propyl halide in particular, instead of getting the expected product, we get a rearranged products. In this particular case, instead of getting your 2-alkyl, that is 2-propyl benzene, you get cumene as the product. With this, I am closing the discussion on this Fridel-Crafts alkylation for today. As usual, if you have any query or any doubt or clarification of the board or my voice quality, please you can send me your feedback. I'll try to rectify in my next class. Till then, thank you. Stay safe. Stay home. Thank you.